IN2STEMPO is funded by the Shift Rail Joint Undertaking, a public-private partnership under the Horizon 2020 framework, established to make rail the sustainable, cost-efficient, high-performing transport mode of choice in the future. IN2STEMPO, innovative solutions in smart power supply, smart energy metering, and future stations. The 21st century railway needs to adapt to the needs and expectations of a new generation of rail users. This includes considering our impact on the environment and designing future stations that are not only functional, but also provide local communities and rail passengers with a range of facilities and amenities that they can expect. It means ensuring our stations are truly accessible to all, that they are safer with improved security, and that our rail infrastructure is more reliable and resilient. The outcome to be achieved is a world-class European railway that embraces the latest innovations whilst minimising costs and its environmental footprint. A railway that puts its customers at the heart of everything it does. Objectives of IN2STEMPO: supporting a smart railway power grid for an interconnected and communicated system, working on fine mapping of energy flows and usage within the railway system, improving crowd management in high and low capacity stations, utilising digital twins and simulations to improve station design and accessibility, improving safety and security for members of the public and rail employees. Smart power supply, developing a railway power grid in an interconnected and communicated way. The railway network of the future integrates smart metering, innovative power electronics, energy and economic management systems, energy storage systems, and environmentally friendly power sources. This will result in improved traffic management to optimise train timetables, a reduction in energy usage with a concomitant financial saving, and reduction in carbon emissions to improve the environmental footprint of the railway. The project facilitates the innovative application of smart control of railway traction systems and the development and control of flexible AC transmission system equipment, improving life cycle costs, reducing energy losses, enhancing interoperability, and improving the attractiveness of the railway system by more sustainable use of energy. Conventional feeding systems for 50 Hz trains are supplied by a contact line system based on simple transformer substations, leading to unbalances and power quality issues. Smart power supply uses power electronics to tackle these issues. By using SVC at the end of a feeding station, reactive power can be compensated, leading to an improvement of the voltage stability and an increase in track capacity. STATCOM can be installed in substations to decrease the unbalance created in the 3AC network and improve the power factor of the supply voltage. The load flow between substations can be further controlled, and double-sided feeding can be enabled by using SFC or RIPFC. It will also facilitate a shift from fossil fuel-based transportation to electrical energy by making railway power grids more resilient and flexible. In IN2STEMPO, the station control and protection system in the railway environment is lifted to the next level by the application of IEC 61850 standard series. The station control bus is supplemented by a process bus according to IEC 61850-9-2, enabling the exchange of the measured current and voltage values between merging units and protection devices in a bus system. Furthermore, the station will send assets and operating data to a cloud, enabling user decision-making tools to process them. The utilisation of smart power infrastructure across the railway sector will reduce operating costs and enable railways to maintain their position as the most environmentally friendly mode of transport. Benefits of smart power supply: increased energy efficiency, optimised power quality, increased system capacity, optimised asset dimensioning, reduction of environmental impacts. Smart metering, mapping of energy flows within the railway system. Currently, energy data is not monitored and managed proactively, resulting in increased usage and inefficiencies. This means increased financial costs, higher carbon emissions, and poorer environmental management and overall sustainability. The railway is one of the largest electricity consumers in the UK and across Europe, but the complex interactions between rolling stock and infrastructure are not well understood. Smart metering aims at building a standard and open architecture, coordinating on-board and ground measurements to provide energy data analytics required to better understand energy flows in the railway network. This data analysis will allow implementation of many new user applications and ultimately the creation of a railway-dedicated distribution energy resource management system. Benefits for operators and infrastructure managers are, for instance, a reduction of energy consumption or an improvement of operating conditions. How does smart metering work? Real-time smart metering will enable synchronized mapping of energy flows within the entire railway system. It's a non-intrusive, open system as well as an interface for data collection, aggregation and analysis. Smart metering and associated intelligence can preemptively detect faults across railway architecture. Benefits of smart metering: considerable improvement of railways' energy efficiency, more value from data, which helps in making operational decisions, eases asset management tasks, contributes to the better planning of investments, minimizes environmental impacts. Future stations: friendlier, safer and easier. Stations are the first point of contact for users of the railway. They are critical in terms of the passenger experience and are one of the most dynamic environments in the European rail industry. However, many parts of existing railway infrastructure are nearing capacity or are incapable of offering users and customers the level of service they demand. Stations need to evolve to address the expectations of 21st century railway passengers and station users. This will involve managing them in a more holistic way, using lean operational practices and smart technologies that can improve the reliability and responsiveness of customer service, as well as addressing the overall economics of rail transportation. The adoption of smart-enabled station architecture will confirm railway travel as the backbone of urban mobility, with stations at the heart of the smart cities of the future. Newer, more modernised stations will improve security, whilst providing easy access and seamless interchange, enabling railways to manage growing passenger volumes and mobility demands. Benefits of future stations: reduced congestion and improved crowd management, improved user experience and reduced mobility passenger support, optimized investment strategy to reduce security vulnerabilities, intuitive and efficient ticketing systems. Railways continue to deliver sustainable transport solutions as overall travel demand intensifies. Modern services can operate with lower operating costs and a reduced carbon footprint, preserving their status as the most environmentally friendly mode of transport and decoupling environmental harm from transport growth. The employment of smart power and smart metering harnesses considerable energy efficiencies and real-time monitoring of asset health, which feeds the predictive maintenance process, while smart stations provide safer, quicker and more enjoyable access to railway facilities, products and services. Benefits of IN2STEMPO: improvement of efficiency of energy consumption and energy forecasting and strategy, reduction of investment and enabling higher availability of the power supply system, improvements in customer accessibility, experience and safety within railway stations, optimized and high-capacity railway infrastructure enabling intelligent asset management.